Last time we talked about how escape velocity works, and that is how to get off of a planet. But let's say that you want to actually land on a planet. How does that work? So today we're going to talk about basically how much velocity you need to land on a planet. And we talked about this in terms of the gravitational well, Earth's gravitational well. And we talked about it in terms of like a ball has an initial velocity. Can it get out of the well? So what we're talking about this time is that the ball starts at the top of the well and then it accelerates down into the bottom of the well and then it hits a wall, which is the planet. If there is a satellite or an object that is far away from the Earth and it has zero velocity, so it's basically sitting there with respect to the Earth with no velocity, you just let it go, it will start to fall towards the Earth. And if you don't do anything, it will accelerate faster and faster and faster towards the Earth, and it will hit Earth with exactly the escape velocity, 11,200 meters per second. So the velocity that you need to escape the Earth is exactly the same as the velocity that if you started with no velocity way far away and you just let it accelerate, that's the velocity that it would actually hit the Earth. And so that's pretty bad because you don't want astronauts and satellites and stuff coming and hitting the Earth at 11.2 kilometers per second. So that means that we need to figure out some way to actually slow down as we get there. And there's a bunch of different ways of doing this. So the first way is that you can decelerate all the way. So basically, as you're coming towards the Earth, you're constantly trying to slow yourself down, fighting gravity the entire time, and you're thrusting the entire time. And then you can hit the Earth with a very safe speed. So that's one way of doing it. But most of the time we don't do it that way at all. What we often do is allow it to accelerate towards the Earth, and then you decelerate very hard at the last second. So you accelerate, accelerate, accelerate towards the Earth, and then at the last second you burn, and then you land safely. The most common thing that we do, though, is that we don't use burning at all. We don't actually thrust at all. We use our atmosphere to slow down. And so what happens is that we allow things to accelerate as they get closer to Earth, and then we aim towards the atmosphere, not at a very sharp angle, but at a grazing angle. And then as we hit the atmosphere, we start experiencing drag. And then if you've seen any videos or anything, then you'll see like the heat shield and everything get very hot and stuff. And that's because the drag force is so large that it's heating stuff up. And that is slowing things down. So instead of hitting the Earth with the escape velocity, you're slowing down in the atmosphere because of drag. And then you come in at a shallow enough angle that you have enough time for drag to slow you down and slow you down and slow you down. And then you use parachutes, and that takes you down to the ground, and you land in like the ocean or on land. So we have done this type of thing on Mars also, and we use parachutes, and then we use thrusters. Mars has a very weak atmosphere. It's not very thick. And so it doesn't work as well on Mars to actually use the atmosphere. So here's a little graphic that NASA put together that sort of demonstrates this. We sort of enter Mars's atmosphere and we use the atmospheric drag to slow us down a bit. Then we use parachutes to take us a little bit closer to the ground, but the parachute is not big enough to actually allow us to hit the ground with a reasonable speed. And so at the very last second, we use thrusters, and that slows us down even more. Venus is very interesting because Venus has an incredibly thick atmosphere. It is much, much, much thicker than Earth's atmosphere, tens of times thicker than Earth's atmosphere. Also, one of the crazy things about Venus is that it rains acid. And so it's actually really, really bad. It's not a great place to visit. And so what ended up happening on Venus is that when we wanted to land on Venus for the first time, we'll talk about this in a different lesson, but we tried to land on Venus using sort of classic methods, parachutes and everything. We didn't understand how thick Venus's atmosphere was, but because we were using parachutes, we started coming down on Venus and we got going way too slow. And the acid rain and the enormous pressure destroyed our satellites. And so we learned pretty quickly that we didn't even need a parachute to land on Venus. We literally just come in and we enter the atmosphere, and the atmosphere is so thick that we basically are buoyant in Venus's atmosphere. And so we can sink down without a parachute at all and land softly on Venus's surface without a parachute. So in summary, soft landing on a planet takes the same amount of delta V as taking off from the planet if the planet didn't have an atmosphere. But we use atmospheres to actually help us decelerate and land softly. And most planets that we want to go to actually have atmospheres. So we use the atmosphere to decelerate, and then we use parachutes to land softly. Some planets we don't need parachutes like Venus, but for Mars you actually need parachutes and thrusters. When we want to land on Earth, we slow down and then we use parachutes and we have a soft landing.